Writing and evaluating arithmetic series. Yeah, I don't know. Is that the right way to say it?
Series.
Siri? Yeah, no, it's not Siri. And then we're going to learn what summation notation is. That first quiz I gave you where I thought I had gone through and taken out all lesson 4 and 5 stuff and it was still on there. And you said, I don't even know what this is. Well, that's what this is. And so we're going to talk about that today. And hopefully you'll understand a little better when we're done. Here we go. All right, arithmetic series is a series whose terms form an arithmetic sequence. And remember, a series is the sum of all the terms. Okay? And then they give us a formula for the sum of a finite arithmetic series. And it says S of n is equal to n over 2 times a sub 1 plus a sub n, where n is the number of terms, a sub 1 is the value of the first term, and a sub n is the value of the nth term, or the last term. So pretty simple. We take the number of terms, divide by 2. We add the first and last term up and multiply the two numbers together.
So it's just like sequences. It's just plug in.
Yep.
Alright, and then do we have an explicit version of this, or is this an explicit term?
No.
Like, does it find whatever term you want?
Yeah, you mean you're trying to make it explicit or recursive. Yeah, we just have one formula that helps us find the sum of all of them. So
Oh, okay.
I don't think it would be proper to term it explicit or recursive. It's just explicit kind of means it finds a specific term. Where here we're just looking for the sum of all the terms.
Okay. And then
That stands for the sum.
oh,
Maybe I should write that down here.
and then one other question about
The sum of all n terms.
Also, like, how do we eventually learn how to transfer explicit, recursive, other sequences into series? Series.
Well, explicit and recursive sequences is just how to find the next term or a certain term of a sequence. That has little to do with this. Now, if I need to know the nth term first, if I need to know the 10th term, I say there's 10 terms in my series, and I need to know what the 10th term is, then I might use an explicit formula like we did in lessons 1, 2, and 3 to find what the value of that term is, and then I'm going to plug it in right here as the 10th term, and I already know the first term, and I know that there's 10 terms here, and so then I can find the sum of all 10 terms.
Alright, so these things are similar to, but not really in the same field as sequences.
Well, it's kind of like learning how to solve a one-step equation before we learn how to solve two-step equations, right? We learned how to undo adding and subtracting. Then we learn how to undo multiplying and dividing. Then we put them together. We have to do both. We're just building on to what we've already learned. We learned how to find the individual terms of a sequence. Now we're going to learn how to find the sum of all those terms.
Yeah, okay.
All right?
So it would only really be necessary for a series of 100 terms, not like for 10 when you could just do it on a calculator. So if you can find I guess it would take a little to find out.
Yeah, you're saying where is this formula valuable? I agree. If there's 100 terms, it's going to be a lot more valuable than if there's 10 terms.
Yeah.
But even then,
But I mean, you won't have all your terms. So.
if there's only 10 terms, it's probably not going to be. Probably most of us are going to be able to add these together without a calculator. And we're probably going to be able to divide that number by 2 without a calculator.
Yeah.
And so we're talking about one calculator operation rather than adding up 10 numbers. I see a very few situations where this formula is not going to be easier and more efficient to use the formula than it would be to use our calculator and just add up all the terms. But certainly you have the right to do that. And if you forget the formula on the test day, then that may be your only option. Hopefully there won't be 100 terms. Besides the fact you have to find all 100 terms, where here all I need is the first and the last.
Yeah.
Right?
I guess.
So in summation notation, this is an example. As I tried to say already, it's impossible to come up with some generic formula for this. And so this is sigma. Greek letter S stands for summation here, okay? And so this summation notation is saying our lower limit is 1. So n is 1, representing our first term, and the upper limit is 10. And so 10 represents our last term, our nth term. And then 6n plus 2 is the explicit formula representing the sequence. And this is what AJ was trying to talk about earlier. We may use the explicit formula to find certain terms, but to find the sum, we won't do that. So how would I find the first term? Say louder, please.
Plug one in.
Plug 1 in. So 6 times 1 plus 2 is 8. And how would I find the nth term, the 10th term? I plug in 10. The advantage of an explicit formula over recursive. And so what would that be? 62. And so if I want to find the sum of the first 10 terms, (62 plus 8). Okay, you're saying times it by 5 because of this, right? And so we get 5 times 70, which is 350. Or I could find all 10 terms, right, Matt? And I could add them all up. You're learning, like it's going to probably be easier to use the formula. So there will be advantage in learning the formula. Should I move this up for anybody? Does anybody need this yet?
Why is it divided by 2 though? Why? I still don't see why it's divided by 2.
It's kind of like finding the average of them. I'm taking the smallest number and the highest number. If I just add them together and divide times by how many numbers there are, there's going to be way too many because they're not all that number. Right? I'm starting with 8 and it's getting bigger each time to 62. So my numbers are not all the same size, are they? So what the formula realized is since there's a pattern to it, it follows the same sequence all the way through. If I take half of the numbers and call them all 70, okay, then when I add up those 5 numbers of 70, it's going to be the same as adding up all the numbers. Because half of these numbers are going to be smaller than the middle, and the other half's going to be bigger than the middle, right? So now how they discovered that in the first place, I don't know. I haven't looked at a proof on why it works. All I know is that it does work every time with an arithmetic sequence, and there's the key. It's arithmetic sequence. Later when we start talking about geometric series, there will be different formulas. Okay, but for arithmetic, this formula right here will work every time. Okay? Any question on summation notation? Yeah.
So you have to use the summation notation formula and the other one in the same problem?
In this example I did, yeah.
You always have to do that?
No, sometimes they'll just say, here's your first term, here's your last term, and what's the sum of all of them? They'll tell you how many there are. Okay, so you just practice and plugging them into the formula. But if you don't have the first and the last term, then you're going to have to find it. Okay?
So, like, this is something for like tests. If there was a story question about this, like, how would it be worded? What would we look for if there's to be something like that? Will there be things like that?
Well, there could be, but there will be practice in the homework on it, if there is. Or at the very latest on the practice test, there will be practice on it. I mean, I can't just make it up. That's a little too involved to make up on the spot. Okay? I'll look through it, and if I find something, I'll talk to you about it. Okay? I want to give you an example of a sequence. Let's say we have 3, 6, 9, 45. Okay? And we want to find the sum of that. We want to first of all write it in summation notation. Okay? And then we want to find the sum of it. So first of all, let's write it in summation notation. So I'm going to pause this so you have some time to think about it. Go back to the notes on what summation notation looks like, what the different parts of it are and what they represent, and let's try to write them.
Right here it has a series.
Okay, I actually changed
3 times 1.
I changed how I wrote this a little bit. I had it written as a sequence instead of a series. So I added the plus signs in there, took the commas out, and then just wrote down the directions what I'm asking you to do. So write in summation notation, then find the sum. Okay?
So could you have me to write that?
Okay, when I'm wandering around, I see things like this. It was supposed to be. It didn't. I have to go slower when it's recording. When I wandered around, I saw things like this. Okay? The sequence was 3, 6, 9, and then we didn't know, and then we knew the last term was 45. That's not n. Those are not our limits. These are the value of each term. My first term is 3. Okay? So n represents term 1 through we don't know yet. And so that had to be a 1 here. Now we can figure this one out. It's not 45. Whoops there. But we can figure this out quickly as soon as we figure out what goes in here.
Did we have to do
Did we have to do
the
what?
E, the sigma?
Yeah. That's summation notation. That was the first thing that it said. Write it in summation notation. Okay? So I want to make sure you know how to write it in summation notation. When you're not always given all the information. I gave you very little information here. Okay, but the first term is 1, not the value of the first term, but n represents what term we're on, so we're going to talk about the first to the however many. So, I got 3, then I got 6, and I got 9. So when n is 1, I get 3. Well, how do I turn a 1 into a 3? Times it by 3, or I could add 2, right? Well, let's try the second one. How do I turn a 2 into a 6?
Can I add 2 to it?
I could times it by 3 again, or I could add 4. Well, I'm not adding the same number every time, am I? So what's my formula going to be over here? 3 times n. Now, we need to know how far we're going. What goes up there? Well, what would n have to be to give me 45? 15.
I don't know what I'm doing.
And so n has to be all the terms from 1 to 15 of the sequence 3n. So that is my summation notation form of writing this series. Okay? Now they said find the sum. Well, I didn't really need any of this up here to find the sum. Except for I needed this number, didn't I? Okay? So I'm going to say, I'm going to write the formula out. A sub 1 plus A sub n times n over 2. Okay? And so, this means 15 over 2 times 3 plus 45. So 15 over 2, that's like 7.5 times 48. And I don't do that too well on the top of my head. 3 what? Oh, that's easy enough. 360. Okay, yeah.
So I did that part first, so I just divided 45 by 3. So would that 15 always be like the same? Like the n over 2, would that n always be on top of the sigma?
Say that again.
Like when I divided 45 by 3, I got 15. So I knew to plug that in for n over 2.
Okay.
Would that n over 2, that n, would that always be what over sigma?
No. No, that worked because what you were really saying is 3n, my formula, has to equal 45. And so you're saying n then would have to be 15 for 3n to equal 45. Well, my explicit formula was 3n minus 7 equals 45. Then n's no longer 15, it's something else.
So,
In fact, that would be a bad example because it wouldn't be a whole number.
n's always what the formula for the last term is, right?
Yeah, n is always going to be the value that makes our formula equal the last term. Does that make sense? Okay. Now, they gave you some examples where they gave you this, 1 to 10 of 2n minus 5. Okay? And they want you to find how many terms first term, last term, and the sum. Okay? So we'll take this example and answer those 4 questions. So how many terms are there?
There's 10 terms.
10 terms. Now, caution. This will not always start with the number 1. I might want to start with the 4th term and add up all the numbers from the 4th to the 10th term. So if that was 4 to 10, how many terms would there be?
6 or 7. Yeah, 7.
4 to 10.
4 to 10.
Oh, yeah.
Common sense might think 6, but remember you're counting the 4th term and you're counting the 10th term. So it's the 4th, the 5th, the 6th, the 7th, the 8th, the 9th, the 10th. There's 7 terms there. So when you're subtracting like that, you always have to add a 1. 10 minus 4 is 6, but then you have to add 1 to count that 4th term. Okay? In this case, 10 minus 1 is 9, right? So I add the 1 to count that first term makes 10. So there's 10 terms. And then the value of the first term, well, when n is 1, what'd you get?
Negative 3.
Negative 3. 2 minus 5 is negative 3. When n is 10, the last term, what do we get? 15.
What?
So we had the sum
60.
was 10 over 2 of negative 3 plus 15 equals 5 times 12 or 60. Okay? So, any questions on that? All right, your assignment, just one second.
Fifty-seven.